I've been seeing something on the internet lately that's pretty awful. It's these thin plywood boxes held together by finger joints and super glue made by somebody on a laser cutter because it's easy. In this video, I'd like to show you a couple of tweaks that you can make to the design so that it's a lot better. But first, we'll talk about the pros and cons of this one. And in order for that to make sense, we'll talk about some joinery techniques and how wood glue works. A piece of natural wood has long fibers that used to run from the bottom to the top of the tree. Each face of the board has properties depending on its relationship to the direction of those fibers. A side grain face has the fibers running along it, and an end grain face is where the fibers were cut. This is also a side grain face. Glue works by soaking into the long fibers where two pieces of wood are joined together. This creates a strong bond that'll hold up, except if one of those faces is an end grain face. This kind of joint will fail quickly. It's called a butt joint. Since gluing butt joints doesn't work, carpenters have come up with different joinery techniques that will hold up without requiring fasteners like screws or nails, which you couldn't fit into thin plywood anyway. In this graphic, and in the rest of them I'll be showing you, I've highlighted all of the end grain faces in red. The more area that a joint has where side grain faces are touching, the stronger that joint will be. So the first answer to the butt joint problem is the dovetail joint. By cutting out these trapezoids, several long grain faces can be stuck to each other. Additionally, the shapes of the trapezoids give the joint a lot of strength in one direction, making it common in things like fancy cabinet drawers. However, a laser cutter can only make perpendicular cuts in the workpiece, so we'll have to leave dovetail joints to the fancy cabinet makers. Another solution is the mortise and tenon joint. The end of the piece on the right is carved away to leave a tenon sticking out, and a mortise is cut out of the piece on the left. The mortise and tenon should have the exact same dimensions to make a strong joint. If you look closely at this picture though, you'll see that the actual side grain surfaces touching each other are pretty small. This slightly different mortise and tenon joint triples the side grain surfaces being glued together and is much stronger. If we extended the tenons so that they stuck out of two different faces, we'd have a finger joint. Finger joints create a crazy amount of side grain surface area to glue together. And by making the fingers even smaller, we just doubled the surface area of side grain wood we're gluing together. This joint is pretty and super strong. So why am I bad-mouthing these twee little boxes? Two reasons. First, this is engineered wood, and therefore has different properties than a natural piece. Plywood only has two side grain faces, and they're sandwiched around a middle that isn't even end grain. It's just sawdust and apple cores and glue in there. Second reason, an industrial laser cutter just cauterized all of the edges while I was cutting them out. Any glue is going to have a hard time soaking through that lasered edge to find some fibers to grab onto. In thicker material, you could use screws to reinforce a plywood butt joint, but that's not going to work in this application. What are the pros of this design? It's easy to do, and it's pretty. There are websites where all you have to do is enter the 3 dimensions of a box you want to make, and they will then create a vector file that you can import into a graphics program to further decorate. If your strengths are in graphic design, that's a pretty good deal. Seriously, this clip is 18 seconds long. The main disadvantage, though, is you've created this twee little box that belongs in an art museum but won't survive in your backpack. Here in America, we expect our trucks to do this. Shouldn't a box be able to survive a little bit of rough handling? Let's give this bad boy a love tap and see what happens. Pathetic. These are all the pieces I could find. Notice what the glue pulled away when the joints broke? Not wood fibers, just gunk and carbon residue from the laser cut. That's why I designed this. The top sides of the interior and exterior walls could have been straightened and offset to secure a lid, but this design uses a bunch of through tenons to lock into a rim for even more structural support. These short ends are purely decorative, but the next 3 sets of walls use interlocking mortise and tenon joints to create a strong, rigid structure. Additionally, the double-walled design allows you to glue the side grain faces of plywood to each other for a strong bond. And the pieces can be cut so that the unfinished edges of the plywood are glued together, leaving finished edges facing both ways. It's a lot stronger too. Love tap in 3, 2, You could put a Fabergé egg in there. I put links below to a design in Autodesk Fusion 360 that you can use to make this kind of a box. Just open up the parameters and change the inside dimensions and material thickness to suit your application. You can download a free trial of Fusion 360 to check it out for yourself. Thanks for watching, and please, let's spare the world any more poorly engineered boxes.